Hello and welcome to Expected Value. Today we're going to look at probabilities where we're looking to see what we expect to have happen, especially when we're talking about the probability of things in the long run. Expected value is kind of talking about if I were to play this game over the long term many times, how much would I expect to win? How much would it cost me on average over the long term? But in general, expected value is just found by multiplying the number of trials times the probability of that happening. So if n is the number of trials and p is the probability of it happening, then we can use the formula expected value equals n times p in general. So some of these problems are pretty straightforward and pretty easy, something like this, where we've got a guy fires at a target at a probability of 2/5 that he hits the bullseye. So his chance of hitting the bullseye on average over the long term is 2/5. In the competition he fires 40 arrows. How many do we expect them to hit? So to find the expected value here, expected value, we would take the number of trials n, which is 40, times his probability of hitting the target, which is 2/5. And that's 0.4, so 40 times 0.4 is 16. So we would expect him to hit the target 16 times. And again, will he hit it 16 times in this competition? No, but that's what we would expect to happen. And if we did 100 different competitions, on average, most of the time, he's going to hit it 16 times out of every 40. Okay? Now this is also used in casino kinds of games when we're trying to figure out how much a game should cost and how much we should expect to win or lose each time we play a certain game. So we've got a game of chance, and the player spins the square spinner 1, 2, 3, 4 and wins the amount of the probability shown in the table. So we have a spinner. If we spin it, if it lands on 1, you win $1. If it lands on 2, you win $2. 3 is $3. 4 is $4. So first of all, we need to see what's the probability of it landing on each of these. Because we've got an equal spinner, each of these numbers is equal, right? There's a 1/4 probability that it lands on 1, a 1/4 on 2, 1/4 on 3, 1/4 on 4. Okay? So we want to see the expected return for one spin of the spinner is going to be the amount of money that we should expect to win from landing on 1, plus the amount of money we should expect to win from landing on 2. So when we're dealing with money, a lot of times we want to talk about money times the probability of it happening. So for ones, okay, the probability of landing on 1 is 1/4. So my expected value is going to be, the amount that I win from ones is going to be 1/4, we'll say 0.25, and that's my probability, and how much I'm going to win is $1. So I should expect to win about 25 cents from ones. From twos, I have a 25% chance of landing on 2, and I'm going to win $2 if I do. So I actually expect to win 50 cents from the twos. I have a 25% chance of spinning a 3, and if I do, I'll win $3, so I should expect to win 75 cents on average over the long term from 3s. And from 4s, I have a 25% chance, and I will win $4, so I have $1 that I win from 4s. So together, my expected value for this game is what I expect to win from 1s, plus what I expect to win from 2s, plus what I expect to win from 3s, plus what I expect to win from 4s. And that's a total of $1, $2, and 50 cents. So $2.50 is what I will expect to win, expected value, expect to win on average over the long term. If I play it 100 times, I should expect to win $2.50 every time. I'll probably win $250. Okay? That's my on average winnings from playing this game. The probability times the money for each possible outcome, all put together. So, should I play this game in a casino if it costs me $5 to play? Step on up, play $5, spin the spinner, you win the money, come on up.
How many times
right?
do you spin it?
Well, in this game, this is my long-term average expected winnings. Okay, I'm only going to get to spin once, and they're going to give me money. So if it costs me $5 to play, is that a good game for me to play? No. I'm going to pay $5, and maybe I win $4. That's still going to be bad, right?
Yeah.
And what casinos will do is they'll figure out, so this is not a good amount to pay. What casinos will do is they'll say, step on up and we'll pay $2.75 to play this game. Right? And I look at it and I say, oh wait, I could win $3 or I could win $4. Let's play. But if people play that enough, they're only going to win $2.50 every time, and the house is going to make money. That's how casinos make their money. So I should only play this game if it costs me $2.50 or less to play. Then I should expect to keep winning if I play. Now if it costs me this, maybe one time I'll win $4, but not every time. Does that make sense?
Yes.
So that's what you do for long-term expected winnings. Same thing with this. Let's say we roll a die, and you win twice the number of dollars as shown on the dice. So if you roll a 1, you win $2. If you roll a 2, you win $4. Roll a 3, you win $6. $8. $10. If the bell rings, just quietly sneak out the door. Okay? So we've got this. This is what will happen when I roll the dice. Okay? What's the probability of rolling a 1? My probability of rolling a 1 is 1/6, and I will win $2 for that. My probability of rolling a 2 is 1/6, and I will win $4 for that. My probability of rolling a 3 is 1/6, and I'll win $6 for that. 1/6, I will win $8. 1/6, I will win $10. And a 1/6 chance I will win $12. So combined, this is my expected value. Should I play $8 to win the game? Well, let's see what we would get here. This is going to be 2/6, 4/6, 6/6. I'm going to keep them a 6 so I have common denominators. And then just add it up. 6, 12, 20, 30, 42. And that is $7. That is my long-term expected value. Should I pay $8 to play? No, because I might win 10 or 12 today, but on average, over the long term, I'm only going to win $7 each time. So I will lose $1 each time if I pay $8. That's expected value. Have a great day.